HoliDes is a European project that aims at improving human factors aspects of development of complex human-machine systems. HoliDes provides methods, techniques and tools that support design of consistent, efficient and usable interfaces. Fatigue or overload is a situation that professionals of all domains face almost every day. The two factors are known to increase likelihood of human error. Therefore, early detection of onset of fatigue or workload and proper mitigation have great potential to improve safety and reduce costs of operations. Statistics show that fatigue was a major cause of about 7 to 15% of accidents of passenger air transport. More than 15 major accidents in the last 15 years are connected to fatigue, and fatigue is identified as number 1 in NTSB Most Wanted List 2016. Even higher numbers are attributed to workload, though the analyses are more complex. Airlines try to fight the problems by improving procedures. However, subjective nature of fatigue and workload requires more advanced approach. In HoliDes, we investigated the use of physiological markers that can be acquired from human body and have connection to cognitive states. We exploit the knowledge of psychology, physiology and machine learning in order to construct machine systems that are able to autonomously monitor and interpret evolution of cognitive state of a human operator. These systems are domain independent and can provide state information to domain-specific systems that can appropriately mitigate a potential deterioration of the cognitive state of the human operator. First of the state monitoring tools developed in HoliDes is the Pilot Pattern Classifier by Technalia. PPC is a supervised learning system that identifies the fatigue or workload of the pilot from online recorded EEG and eye tracker data. The classification model uses 31 features. Cognitive Distraction Classifier by TWT uses video recording of face in order to recognize level of distraction. Eye closure, eye blink rate, angle of sight are among more than 20 features that contribute to supervised learning and recognition. Missed Event Detector by BUT identifies head and gaze orientation from the video recording of upper body parts. Though it is not able to detect what the human sees, it can detect what the human cannot see and match it with possibility for humans to miss important events. The tools interpret biosignals and behavior in order to identify a set of features, e.g. blink rate. The features are used first to train a classifier based on supervised machine learning. Once satisfactory performance of a classifier is achieved, the classifier is deployed to identify the state of human operator in real situations. State of the pilot can be used by a machine system to provide necessary assistance in order to reduce a risk of error. The assistance can be in form of a warning or an adaptation of HMI. The adaptation of HMI must be comprehensive and unobtrusive to avoid confusion of the pilot and to reduce time needed for the pilot to get oriented in the overall situation. Several approaches for detection of pilot cognitive state in the cockpit have been investigated in HoliDes project. Generic tools for interpretation of physiological and behavioral data were developed, and their output was demonstrated as adaptation trigger in a real cockpit application, Diversion Assistant. Though the maturity of integration reached in HoliDes project has not been high, the tools proved to be useful and can be further exploited.